Good morning, Miss. Back to my channel, and today I'm talking about lesson 4, erosion and deposition by wind and ice. So, wind, ice, and gravity. And let's see here about the pointers I have. Wind, ice, gravity. Okay, so we're going to be taking this lesson step by step. Wind, ice, gravity. So let's go on the vocabulary words here. Dunes, losses, glacier, glacier drift, creep, rockfall, landslide, and mudflow. Okay, so let's get on with the lesson. So, wind. Okay, wind can abrade rock. The grinding abrade is the grinding and wearing down of rock surface by other rocks or sand particles. So, let's imagine this. You have a big rock. Big. Wind is blowing that way. Or let's say east, west. Okay, so the wind is blowing from west to east because I'm facing north. West to east. And this is the rock in east. And wind is taking sand from under it and taking it. The sand will just hit the rock and the friction will make these rocks smoother and finer so the wind can break it down easier. And that's abrasion or the abraded rock. And sorry, miss, I have construction right beside my house. So this is abrasion. Desert pavement has a part of it called deflation, or the removal of fine sediments by a wind is called deflation. So yeah, the removal of fine sediments is deflation. So let's say my head is sand, okay, and my head is sand. After it, wind, breeze, okay. Suddenly, oh no, I have no hair because it is lightweight, so the air just blows out my sand. So yeah, so that's deflation. Okay, so now we have abrasion and deflation. Next on the list we have dunes and losses, and that's all wind. After wind we have wind, ice, and gravity. Yeah, so let's get on. Wind can also be dunes and losses. Dunes is a mound of deposited sands. So let's say we have the wind direction is going that way. After it's going that way, yeah, sand is being blown with it. And when the sand slows down, the sand is very far from the ground. As the wind slows and gravity takes place, the sediments or fine particles get pulled to the ground, forming dunes. And that process happens almost every day. After that, we're gonna have a slope, or like slope. That slope is a rough side and a smooth side. Smooth side always face parallel to the wind, but the bumpy side is actually against the wind. And I don't know what is the science behind it, or just air dynamics, I think. So yeah, now losses. Losses is thick. Let's put this down. Losses is thick deposits of wind-blown fine-grained sediments known as losses. Okay, and actually, yeah, we get. All the pictures that I'm showing up here is actually from the book. Okay, it's written below it, property of the book. Okay, so I won't get copyright. Okay, so now we know that is wind. Let's just check out losses. Okay, so now we have wind. Let's go to ice, known as glaciers. So we have three kinds of glaciers. Okay, there are flowing ice, alpine glaciers, and continental glaciers. Okay, so after this, we are gonna talk more about ice. Okay, so ice. Okay, first vocabulary word on the notes: glacier. Glacier is a large mass of moving ice that is formed by compacting of snow and natural force. Okay, so that's a glacier. And let's say you think a glacier is like an iceberg, right? Well, you're wrong, because iceberg is just a small part of a glacier. When a glacier breaks apart or it gets cooled, a part of the glacier breaks. That, my friends, is an iceberg. And you might be saying, an iceberg? Wait. But an iceberg sunk Titanic. Right. It did sink Titanic. That means we know icebergs are huge and destructive. Glaciers are even more destructive, because we have a kind of glacier known as continental glaciers, which are all over continents like Antarctica. Yeah, Antarctica. So, the kinds of glaciers. Okay, so the kinds of ice or glaciers are flowing ice, alpine glaciers, and continental glaciers. But there's also something called a flowing ice. But what does ice got to do with glaciers? Glaciers is compact snow. Ice is hard, not soft. Yes, but flowing ice actually got a part with erosion and deposition. Let me tell you, when ice goes downhill, friction heats up. It makes like a liquid layer. That liquid layer gets basically the ice is a huge glacier. Let's say chunk of ice. Okay, a big chunk flows downhill. Okay, it flows down a mountain. It just picks up, breaks rocks, and erodes material and deposits it because liquid, ice, liquid. Okay, so now we know flowing ice. So, what's an example of flowing ice? Good question. And what's an avalanche? You go okay, for example, you go hiking, and then while you're going hiking in the mountains, Himalayas, okay, then suddenly you see, oh, you hear a sound, okay, the ground is shaking. You look beneath you, you see piles of snow just rushing down the mountain, picking up rock and erosion, and you're on the top of the mountain getting ready to hike down. And the way up, you took pictures. You go down the mountain, you say, oh, that's not like what I saw. It's because the snow eroded and deposited the rocks. Look at your pictures. The ground is completely different. So that's an example of flowing ice. Alpine glaciers. Okay, an alpine glacier is a glacier that formed in mountainous areas. Okay, mountainous areas, and it flows down the side of a mountain and creates rugged landscapes. Rugged. Okay, so it flows down a mountain, rugged landscapes, and explains itself. And they may form in valleys or originally created by stream erosion. So the glaciers, alpine glaciers, flow down mountain or just down the mountain, and makes a rugged landscape. So just okay, and that's an alpine glacier, and it forms a V-shaped valley. Okay, this is the picture, and yes, this is from the book because Google is cuckoo. Yeah, so I got these pictures from the book. And yeah, and when three or more what's it called, Arctic, a sharp ridge, okay, is an alright. When three of them or more are ties, alright, join, they form a sharp peak called a horn. Now that's scientific. Okay, and sorry miss, I couldn't send you this video in Thursday. I mean in April 7 or Wednesday, right? Yeah, in Wednesday, because I was actually sick that day. Yeah, I was actually crazy sick. It turns out I ate something bad, so yeah. So Wednesday, Thursday, and Friday, I was horribly sick, so I couldn't do when the homework, and yeah, and I couldn't do my Arabic homework on Thursday, and you can ensure that with Mr. Ayman to prove that I'm sick, because I'm not joking, and you can ensure with my dad. So these are alpine glaciers. Continental glaciers, okay, are thick sheets of ice, okay, and they go all over a continent like Antarctica, and they smoothen and flatten the ground in front of it, unlike the alpine glaciers, which is a rugged landscape. So now you can just check alpine and continental and flowing ice off our list. So now we have gravity. Okay, so now we have to go to gravity, which is the last part. But before I want to go to gravity, my landscape looks bad, or the background. So I'll change it, so I can just do this. Okay, yikes, bad landscape. Next landscape. Oh, oh, same background. Never mind. Okay, so let's get on to gravity. So we have two kinds of mass movements called slow mass movements and rapid mass movements. So what's the difference? Except that one is slow, one's fast. That's it. They're just slow and fast. And that I can only name one slow mass movement and three rapid mass movements. That's the difference. So one slow mass movement is creep. So creep is the extremely slow movement of material down slope. Is called a creep. Yeah, that's a creep. Extremely slow movement of material. And you might be saying, movement of material down slope? How would the trees look like if they're going down slope? Let me tell you. It'll look like this. Bad, right? Yeah, I know. That's why it's creepy and scary and looks haunted. And yeah, this is also from Houghton Mifflin Harcourt Publishing Company. Yeah, our book. Yeah, and the rapid mass movements. The rapid mass movements are rockfall, landslide, and mudflow. So yeah, I'm gonna name one slow, three fast. A rockfall, okay, is when boulders, okay, up in like huge hills or possibly mountains or cliffs get too heavy, or just a storm came or just rain. These huge boulders just go downhill. Okay, just crash. That's fast. And they kill people and destroy houses and some of us. So good thing Qatar is a desert and there's no boulders and we have very little precipitation. No storm, no rain, no cliffs. Humans will destroy everything. Technology will rule over the world, so yeah, we don't need to worry too much about that in Qatar, but in some places there we should worry about them. Landslide is the sudden or rapid movement of a large amount of material downslope. What? Oh, okay. So a landslide is a lot of large amounts of material, let's say a ton of sand, rocks, mud, and then they just go whoop, destroy everything in their sight, bury people alive, kill us. That's rapid, it's not slow. So that's a landslide. A mud flow is when large mass of mud or just a lot of soil, sand, sediments, scientific vocabulary, sediments get mixed with water and rain, and that just creates mud. When mud is slippery and it's in a steep place, it just covers everything under it with mud and gets sticky. It sticks people. They can't move. They might drown in it, and then they die. So everything is bad in rapid mass movement, and most of them happen in 80 miles an hour. So that's around I count 15 miles an hour. So that's a possibility that it is nearly 5 times my speed, or 6 times. Yeah, 6 times my speed. Yikes. No, 5 times my speed, 5.5 times my speed. Yeah. So that's it for today, and hopefully you like it. And my camera quality is better because I'm doing off my phone, and I actually have a tripod, and the way that I'm doing this without touching my phone is with this remote control. Every press I do, I just open and close the camera. So yeah, hopefully you like this video. Hopefully I get a good mark and lose the fact that I late submission. So yeah, hopefully you liked it, and goodbye. If you like this video, you can share this video and hopefully you like it, and please subscribe and like this video, and click up here for more information, and if you like Science Kid of the Future, give this a thumbs up, subscribe, turn on post notification. Goodbye.